Hi, Miss Marion here. Go ahead and turn to page 141 and go ahead and read the I can statements. I can understand what the solution to an equation in two variables is. And I know that the graph of an equation is a visual representation of all the solutions to the equation. This is what we're covering for today. Go ahead and give yourself a sentence and then also a number. 1, I don't remember. 2, I kind of remember it. 3, I remember, but don't ask me to teach it to my friend. But then 4, I do get it, and I can also teach it to my friend. Give yourself a sentence and the numbers 1 through 4. So our goals for today is to be able to comprehend that points on a line on a graph of an equation represents exactly the solutions set of an equation of a line. And we can create a graph and an equation in the form of ax plus by equals c that represents a linear relationship. And we're going to be able to determine pairs of values that satisfy or do not satisfy a linear relationship using an equation or a graph. And again, all of these will make a little bit more sense once we're done with the lesson for today. All right, let's go ahead and turn to page 101. And will you go ahead and answer the question, which figure has the largest shaded region? Go ahead and answer that question. Write your answer underneath the pictures. Go ahead and pause right now and answer that. All right, if we actually look at it really carefully, figure C, figure A, and figure B have the same amount of shaded region. This is 3/4 of the whole square. So just kind of look at it, play with it a little bit. It's okay if you got it wrong. It just kind of makes us kind of think, getting our brains going for math for today. All right, let's go ahead and turn to page 109 through 110. We're going to go ahead and go through activity number 2. So activity number 2 says, at the corner produce market, apples cost $1 each and oranges cost $2. So let's go ahead and let's answer number 1. Find the cost of 6 apples and 3 oranges, 4 apples and 4 oranges, 5 apples and 4 oranges, and 8 apples and 2 oranges. Go ahead and pause right now. Go ahead and answer those questions, and then we'll go through it together. All right, let's go ahead and go through it ourselves. So if we have 6 apples, they are worth $1. So we're going to say 6 times 1. And then we have 3 oranges, and they are $2. So we're going to do 3 times 2. So 6 times 1 is 6. 3 times 2 is 6. So how much do they spend at first? $12. Let's go ahead and do the 4 apples and 4 oranges. So I'm going to erase what I had before so I have some room. Okay, so 4 apples, so 4 times 1, because they're $1 each, and then 4 times 2 for the oranges. 4 times 1 is 4. 4 times 2 is 8. 8 plus 4 is 12. So they spent 12 on the first one, and they've spent 12 on the second one. Let's go ahead, I'm going to change my colors to make it a little bit easier. 5 apples at $1. 4 oranges at $2. 5 times 1 is 5. 4 times 2 is 8. 5 plus 8 is? Yep, you got it. We're going to go and spend $13. Then let's go ahead and do the last one. 8 times 1 is 8. And then we have 2 times 2, because 2 oranges at $2. So we have 8 plus 4. 8 plus 4 all together that we spent is $12. Now, since we've actually went ahead and played with this just a little bit, let's talk about Noah. Noah has $10 to spend at the produce market. Can he buy 7 apples and 2 oranges? Go ahead and pause and answer that, and then we'll come back together. So let's go ahead and let's figure it out. So 7 apples. So 7 apples, it is $1 for 7 apples. We have 2 oranges, it's $2 for 2 oranges. 7 times 1 is 7. 2 times 2 is 4. Let's add it together. All of that will be $11 total. So can he buy the 7 apples and 2 oranges? No, he doesn't have enough money. Let's go ahead and look at number 3. What combinations of apples and oranges can Noah buy if he spends all of his $10? So you're going to need to go ahead and kind of pause this and kind of figure that out. There's a whole list of different things as far as this will be, and let's see how many you can actually figure out. All right, now since you kind of worked through it, let's go ahead and figure out what combinations he can actually go ahead and buy. So first of all, we can have 0 apples and 5 oranges. Next, we can have 2 apples and 4 oranges. We can have 4 apples and 3 oranges. We can have 6 apples and 2 oranges. We can have 8 apples and 1 orange, and we can have 10 apples and 0 oranges. So these are the combinations that we can actually go ahead and have for the $10 that Noah wants to go ahead and buy. All right, let's look at number 4. Number 4 says, use 2 variables to write an equation that represents $10 combinations of apples and oranges. Be sure to say what each variable means. So go ahead and pause right now and write an equation of what it is. So let's go ahead and let's write the equation. So I'm going to say that A is going to represent number of apples. And I'm going to change my color. And I'm going to say O is number of oranges. So notice how I labeled what my A and my O is going to represent, because if we don't, we really don't know what's going on. We can assume, but again, mathematicians don't like assuming. So we're going to go ahead and figure that out. So let's go ahead and let's write an equation. So it is $1 for every apple plus, how much were the oranges? Oh, they were $2 for every orange. And all of that is going to equal the $10 total that Noah has in his pocket. So A plus 2O equals 10. So what are 3 combinations of apples and oranges that make your equation true? And then what are 3 combinations of apples and oranges that make it false? Go ahead and answer both of those together. I think they kind of make a little bit sense, and figure that out. So go ahead and pause and answer those questions. So let's go ahead and kind of look at that. That actually kind of is the answer to, as far as number 3 for number 5. So what are 3 combinations of apples and oranges that make your equation true? Well, I can say that I can have 2 apples and 4 oranges. Because 4 times 2 is 8, plus 2 apples at $1, that makes our 10. What else can I do? I can say, oh, I have 4 apples and 3 oranges. And let's write one more. I can do 6 apples and 2 oranges. So, and then what are 3 combinations of apples and oranges that make it false? Well, any number of those that will not add up to $10. So like number 2, Noah had 7 apples and 2 oranges. That did not add up to $10. It added up to 11. So there, we can actually do 3 combinations of those two different kinds. All right, let's turn to page 111. And we have 2 numbers. If you double the first number and add it to the second number, the sum is 10. So we're going to kind of work with this wording. And so let's say X represents the first number and Y represents the second number. Write an equation that shows the relationship between X, Y, and 10. So go ahead and pause for a second and answer that question. So if I was making the equation, so the first number it says if you double the first number. So doubling is timesing by 2, and the first number was x. So I'm going to say 2x plus, and then what did we do with the second number? We just added it to the second number. Okay, so add to the second number, which was y, and then all of that is going to, so the sum is the answer to an addition problem. So the sum, and then is, and then 10. So addition of the 2 equals 10. So this is our equation for, we have two numbers. If you double the first number, add it to the second, then the sum equals 10. So that's our equation. It says plot at least 5 points on this coordinate plane that makes the statement and your equation true. What do you notice about the points you have plotted? So we need an x value, and then we need a y value, and we need to go ahead and find different points along with it. So go ahead and do at least 5 points. Pause and go ahead and do that. All right, let's go ahead and figure out some points that go along with it. So I'm going to go ahead and go, okay, what if my x was 3? So I have 2 times 3 plus y equals 10. So I have 6 plus y. So what does my y need to be? My y needs to be 4, because if I do 6 plus 4 equals 10. So my first point is 3, 4. All right, let's pick another point for my x. Let's do 1. So let's change that color, make it a little bit easier. So if I say x equals 1, so I have 2 times 1 plus y equals 10. So I have 2 plus y equals 10. So 2 plus something will equal 10. Well, that y needs to be 8. So what's my second point? Oh, 1, 8. So as you can kind of notice, we can go ahead and make different points with it, and you can figure out different points that satisfy this equation itself, and then we're going to go ahead and plot those. So go ahead and keep on working on more of those. So if you haven't done it before, we're going to go ahead and do more of those. All right, so I went ahead and added some more points. I have 0, 10. I have 2, 5, and then I have 4, 2. You can go ahead and test those and make sure if they're correct or not. And then now we need to go ahead and we need to plot those points. So go ahead and you can plot yours. You can also plot mine and go ahead and plot those points. So we have 3, 4. We have 1, 8. I have 0, 10. 0, 10. I have 2, 5. So over 2, up 5. And then I have 4, 2 over 2. Or sorry, up 4 over 2. So what have we noticed? Well, I have noticed that these lines, if I connect them together, these points make a line if I connect them together. All right, let's go ahead and list 10 points that do not make the statement true. Using a different color, plot each point in the same coordinate plane, and what do you notice about these points compared to your first set? So we need to put points in so that it does, like if we do 2x plus y, it does not equal 10. So that's kind of what that means. And you can go ahead and look at that and see what happens. All right, I found all these points that did not make it so the statement was true. So I have 0, 0, 0, 2, 2, 2, 2, 10, 3, 7. So I'm going to go ahead and I'm going to plot those points. So we have 0, 0. We have 0, 2. Over 2, up 2. We have 2, 10. It's over here. And then we have 3, 7. That's over here. So what's going on with these points that do not make the system right? So if we look at 0, 0, I go 2 times 0 is 0, plus 0 is 0. That does not equal 10. If we actually put them into the equation, they do not make both sides equal. So the number, if we put numbers in for x and y, it does not equal the 10 that we're actually looking at. So what do we notice? Well, these points, they do not make a line. They're not on the line that we talk about. And so these are actually considered not a solution to what we're trying to do, the 2x plus y equals 10. And so if those points are on the line that we made, then they are solutions. And if the points are not on the line, they are not solutions. Or if we put points into the equation and both sides are equal, then it is a solution. Or if we put points in the equation and they're not equal on either side, it is not a solution. So this is kind of what we are looking at for today and looking at that. So here's another example of answer for page 111. So what we're looking at is a solution to an equation with two variables. What it is a pair of x comma y that make the statement true. So if we were looking at this example here, 1 comma 3 is on this line, so it makes this equation true. 2.75 comma 1.25, it's on the line, so this coordinate x comma y makes the statement true, and the statement that we're looking at is 2x plus 2y equals 8. So this point, if I put in here, both the sides will be equal, and if I put the 1 comma 3 into the equation, both sides will also be equal. So that's what makes it either a solution or not a solution. So go ahead and turn to page 113. There is a glossary term for solution to an equation with two variables. Go ahead and write down the definition for it. So you can either put it in your terms, or you can say a solution to an equation with two variables is any pair x comma y that can be used in place of the variables to make that statement true. Go ahead and do a definition for the solution to an equation with two variables. So let's go ahead and let's go back to page 141. And let's go ahead and write yourself a sentence and give yourself a number about, you can understand what the solution to an equation is in two variables. That's what we just barely did. And we know that a graph of an equation is a visual representation of all the solutions to the equation. So that's kind of what we've done on both the activities for today. Give yourself a sentence and a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So let's go ahead and make sure that we go ahead and do the practice problems and go ahead and go from there.